Hello to all of our listeners. Welcome to our podcast on edge computing. My name is Lisa Neddam. I lead our IBM business in the French-speaking part of Switzerland. I'm also responsible for our software services and our ecosystem in Switzerland. And today I have the pleasure to be joined by Mahaveer, who is one of our experts worldwide when it comes to edge computing. Welcome, Mahaveer.
Thank you, Lisa, and I'm glad to be part of the podcast today.
It's great to have you. I think it's a very, very interesting topic for our listeners today. Edge computing it's one of the topics that I would say is very much in fashion. We hear a lot about it, but I think for many of us, it's still quite difficult to grasp and really understand what it is. And so hopefully in today's introduction to edge computing, we'll be able to kind of provide an overview of what it is, what it does, what the value proposition is, and how our listeners can get started with the organizations if they're interested in exploring it further. And so we in our world are connected all the time, be it with our smartphones, with our laptops. And I think with the Internet of Things, this is going to keep increasing. And from my point of view, this is why edge and edge computing is becoming so relevant. But maybe for our listeners, could you explain what we mean when we say edge computing?
Great question, Lisa. The edge computing, if we look back, our era of computing, which started from mainframe, right? The mainframe era was all about decentralized way of computing. You had customers and enterprises had data centers spread across the world, and their applications were hosted in those data centers, and the mainframes were used for computing. Then the generation of computing started changing. They started changing from decentralized way of computing to the centralized way of computing when the public cloud came into the play, right? Now, the pendulum moved from decentralized to the centralized computing. Now, the era now has already come, where now the data tsunami has started. The data tsunami has started. To give an example, by 2022, there will be close to 90 billion IoT sensors and edge-related devices will be operating in the edge locations. It could be your manufacturing, it could be your retail, it could be airport, it could be any edge locations that you think about, which is behind the firewall. They are going to be generating enormous amount of data, right? Close to 175 zettabytes of data by 2024. Now, if you think about bringing all the data back to the cloud, that's going to cost a lot to the customers, and it's going to create a latency. And that's exactly what made the edge computing generation to happen. So the pendulum is back to the decentralized way of computing, and the edge computing is a way of distributed computing paradigm that brings the computation and data storage and processing of the data closer to the location where data is created, and requires processing of the data and also to helps make decision making to organizations. So it's computing. Edge computing is all about bringing the cloud computing in the smallest way as it's possible to nearest place where the data is created, where the application needs to run.
Very interesting. And can you give us a few examples of what those edges would be, and where you would draw the line between edge computing and indeed cloud computing?
Great question, Lisa. You can think about, as I mentioned, your ATM, your car, the cameras that are installed across the manufacturing unit, at your home, any place that you can think about, the cameras, the security cameras, manufacturing units, the airports, retails, the data centers, right? Transportation. All of these are called as edge locations. Why? Because all of these locations have a data created, and how the data gets created is the applications are running there. The applications running there, and human is interacting with the devices and servers and clusters at these edge locations, and every interaction creates the data, and that data is at the edge, created at the edge locations, and these are some of the examples of edge locations. And how do I draw a line between it, cloud computing and edge computing? Cloud computing is needed in the future as well, where you need to host your centralized computing or applications. Like take an example of SAP, take an example of Oracle functional DBMS, where the enterprise level of application that is needed for the bigger level of computing, the fast, that is where the cloud computing is needed, right? It could be hybrid cloud, multi-cloud. However, the edge computing is all about bringing the subset of that cloud computing to the edge locations for faster, processing of applications, faster decision making. So you basically bring subset of the cloud computing to the edge locations to process the data much faster and make the decision much faster, right? So that's the difference between the cloud computing and edge computing. If you ask me one other question, will edge computing going to replace cloud computing? No, edge computing and cloud computing are solving two different purposes, located in two different locations and solving two different use cases. They would not replace each other, but rather they would complement each other. They work tangibly each other.
Very interesting. And you've already mentioned one use case, which is, you said multiple times, being able to make decision faster. What would you say are the other maybe use cases, triggers that would be a motivation to look into edge computing?
Yeah, so great question again. There are four imperatives that problem the edge computing solves. As per the Gartner and even other reporters and analyst has mentioned this again and again, and we have seen some of the use cases as well. The number one is latency. Latency issues. How does edge computing solve latency issues? If you are looking to bring all of the data to the cloud, you need X amount of bandwidth. Now that bandwidth could actually cause latency issues because you have to bring the data has to be analyzed in the cloud, and then you get the decision back to the edge locations. So that creates a latency issue. So now the edge computing reduces latency issues by doing the computing at the edge locations. The bandwidth, the second one is the bandwidth cost increase. If you still continue to bring the data back to the cloud, you need to continue to increase your bandwidth requirement and bandwidth ask with the customers. With your cloud provider. So that means your bandwidth requirements keep increasing, that you mean to say that you need to keep paying for your bandwidth requirement. The third one, the big one, is disconnected operations. The disconnected operations, when you're operating at the edge locations, as I mentioned before, even though the 5G is already in play, however, the customer is expected to continue to operate using the Wi-Fi or low technology enablers called LTE, and as well as use the Bluetooth technology. So in those scenarios, the customer is expected to have a disconnected operation or low latency, a low network connection. When that scenario happens, the customers should be able to operate without worrying about the connectivity, and that's edge computing solves that problem. But the last one and the big one, we're not forgetting the security issues and the compliance related issues, and also we call it the law of the land regulations. Take an example in the European sectors, the GDPR comes into the play, where some of the European sectors cannot take the data out of their country or even the counties. They expect to keep the data within the country and operate and process the data within the country. And the edge computing exactly solves that purpose. Adopting the edge computing is all about processing the data locally and keeping the data locally. And you bring only the amount of data and subset of the data processed at the edge location back to cloud if there is a requirement for storage, right? So those are four big problems or imperatives that edge computing solves.
That's very interesting. And the last use case that you mentioned, I think, is particularly relevant, obviously, for us in Europe, in particular, also in Switzerland, here with a lot of regulated industries. And I think is probably going to be one of for many of our listeners to look into Edge. Um, if you're trying to combine what you just described with a hybrid architecture where you have some data remaining at the edge and maybe a subset of that data or a selection of the data that goes to the cloud for storage, do you see any kind of limitations in terms of what can be processed at the edge versus in the cloud? Is there a limitation in terms of data size, volume, that you would that listeners would have to take into consideration when thinking about a use case?
It totally depends on the use cases, right? My straight answer for that question would be there is no limitation as such. The limitation that you can do the computing the same way that you do the computing at the cloud computing, right? But however, the limitation would be if you're looking for larger transactional related computing to be done at the edge, that may not be relevant, that may not be the right place to do it. Take an example of bankings, right? Where they are looking to do the transaction and data approvals or payment approvals. Typically, you don't do it at the cloud, at the edge, rather you would do it at the cloud. That could be one of the limitation, right? There could be other limitations at the edge locations, but however, it totally depends on the use case that the industry is looking to solve. So that's the reason I took one example as a bank where they actually process these transactions and they store the data in the cloud computing. Those are typically not for the edge requirement. Those are for the cloud computing requirement.
And I guess I'm assuming it also depends on what the edge is, right? And that's what you were saying about the use case, because an edge could be as small as a Blueberry Pi or a phone, but it could be as big as a laptop or even a small server, I'm assuming. It depends on the scale of the grid, right?
Yeah, just to kind of add to that point, now a lot of customers are looking to even build their private public cloud at the edge locations. Take an example of IBM Cloud Satellite. IBM Cloud Satellite exactly trying to solve the requirement of the customers at the edge locations. The manufacturing units, telcos, right? The hospitals, and many other industry verticals, now they're looking saying that, hey, I have a privacy problem, I have a data regulation issues. Now, I want to build a cloud, a private cloud or a public cloud at my location. And the IBM Cloud Satellite exactly solving that requirement to actually deploy the Kubernetes at your location and the services that is needed to run those Kubernetes at your location. So providing you that option of building your private cloud at your location, and with IBM Edge Application Manager, you can deploy the workloads and make the workloads run on those Kubernetes, right? So you're right. As small as Raspberry Pis, IoT sensors, a 3-node cluster could also be at the edge location, but however, it's now becoming larger. The larger, in a sense, customers are looking to build the cloud satellite location. That brings a great point. I would say the customers looking to, and enterprises looking to solve the purpose of cloud out, edge in requirements. That means you can bring the cloud out of your centralized cloud and build your own cloud on your location and your edge location. Edge in means you can bring some of the process data from your edge locations into the cloud. So it's cloud out and edge in is what companies like IBM, Microsoft, and AWS looking to solve.
That's very interesting. And I'm assuming, coming back to your earlier point about being able to make decisions quicker at the edge, that does involve AI and analytics. And maybe you can tell us a little bit how those two components work together.
Oh, a great point. I'll actually you taken a use case to answer that question. One of the manufacturing company, they were looking to improve the lack of efficiency while maintaining the quality, and also they were trying to reduce the regular downtime caused by various issues, and that was impacting the production throughput. So they had various problems: efficiency problem, downtime problem, production throughput was decreasing. So all of these problems were causing for various reasons, right? And they were not able to detect the exact issue in a real time. So what they did is they actually developed the AI-powered automated inspection solution using our IBM Maximo Visual Inspection and deployed to the edge location using IBM Edge Application Manager to detect the issues, anomalies, within few fraction of milliseconds, and alerted the supervisor saying that, hey, there is a problem that you need to take care of it. Right now they have visibility into the issues and maintenance much faster than what it used to be before. Now they solved probably the production throughput issues. They solved the quality issue. Now they also improved the efficiency, because now the way in which efficiency was increased, because now they were able to deploy these AI machine learning analytical model using IBM Edge Application Manager, using one or two admins in an efficient way, in a faster way, and at scale, because IBM Edge Application Manager can deploy AI machine learning models, an analytical model at a scale of 100 to thousands, right? So that's another way of increasing the efficiency. That's a use case that we actually solved, how AI and Edge works together, solving the customer use cases. And what was the result there? I wanted to kind of extend that to say that result of having AI, Edge working together, this manufacturing company which I mentioned, they saw 5x increase in inspection efficiency. They actually saw 20% reduction in false positive defect detections. And also they saw 20% cost saving on a software maintenance and deployment. So that's the outcome of AI and Edge working together.
That's great to hear. And that's actually exactly what I was going to ask you is, what's the business case for Edge? But it sounds like in your example, it's really multifaceted. It has an impact on efficiency for your business. It has a financial impact. What would you say are the other factors that are coming into play when you build a business case for Edge? And I would add to that, what is triggering the fact to do it now rather than waiting and doing it later?
Yes, the customers can ignore adopting edge computing now, but there might be chances that it might be too late if they want to think about it later. The digital transformation is driving that to happen. If you take an example of manufacturing units, I'm giving one example there. They're already in the path of what we call as Industry 4.0 revolution, right? The Industry 4.0 revolution can happen only through digital transformation and edge computing and bringing the right set of workloads. It's called smarter factories, right? So the generation of computing is changing, right? The organizations and enterprises are forced to adopt the new way of computing, right? And a lot of business models that require faster insights, decision making, and reducing the latency. And that's the reason a lot of enterprises are already adopting edge computing. And those are not looking into it. They're not, probably aware about it. I would request them to, start taking a look at it, educate yourself, and reach out to us, an IBM team. We can help you, guide you through that. But some organizations who tend to ignore, they probably need to accelerate their decision making much faster, right? And and other areas where customers are looking to adopt edge computing is because they want to improve their customer experience. If you increase customer experience, it creates a new way of revenue creation model, right? That's one of the reasons why organizations are looking to adopt edge computing, and we urge them to start thinking about it and start making decisions, and we are here to help you.
That's great to hear. And I think one of the points you mentioned earlier, which I think is really key, is you spoke about Kubernetes and in fact, being able to leverage container-based developments to then push them to the edge. I would assume that one hesitation on client side could be to go towards the edge, could be that simply they don't know what their edge devices are going to be. in the near future. And so they're waiting to kind of get visibility on that. But it does sound from what you said that if you have the ability to develop once and then push your development through containers to any kind of edge, you're kind of overcoming that challenge and that uncertainty, because you may have some edges today, they may be different tomorrow, but effectively you're going to be able to develop once and push them to the new edges as they come along. Am I right in this assumption?
You're absolutely right. The journey of the containerization accelerated by edge computing. A lot of customers, in fact, I would expect 99% of the customers expected to use the containers, either it is Podman, Docker, or it is even Kubernetes, as part of the platform to run their application at the edge. So it's not only digital transformation, it is also what we call it as a cloud native way of operating, or edge native way of operating is what edge computing brings to them, right? It's a transformation, it's an overall transformation, it brings to the customers. AI, containerization, edge computing, cloud native way of operating, that's the way to go.
And you mentioned earlier that you mentioned one example of a very specific use case. I'm assuming from what I just heard from you that use cases are actually cross-industry, right? There must be use cases in almost every industry. Do you confirm that?
Yes. Edge plays a significant role across the industry verticals. I'll give you examples. I talked about manufacturing. I'm going to talk about transportation. Then in the transportation, it could be railways, it could be bus transportation, right? Where the customers are looking to improve customer experience by acting on data in real time and reduce cost of operation. Smart vehicles we talked about to improve the driver experience and reduce cost of operation. Kiosks, the kiosk, a general purpose kiosk or ATMs, where the customers are looking to bring the way of software deployment methodology, lifecycle methodology to improve the client experience, lower the cost of operation, and bring the higher security. Same goes with healthcare, to kind of bring that improved health outcomes, reduce the cost, and as well as take care of the data privacy. Right, in US, countries like US and in Europe as well, you can't really take the data out of the hospitals because of the privacy issues. So edge computing solves that. And then we have agriculture, smart agriculture. We have companies in Germany we are working with to leverage sensors, smart gateways, and monitor the systems to optimize the farming decision making and increase the output and reduce the stage. Other big one I've seen in retails. Retails are looking to improve the customer experience by reducing the operational cost and as well as improve the inventory management. So as you see, the edge computing, is kind of spread across in many industry verticals with the very specific use cases that it's solving and bringing the value to the clients.
That's great. And I love the example you also mentioned about smart agriculture. And I remember when I was involved in a similar project that, in fact, it's not just a matter of having, greater latency or reduced latency in that case, but in many cases, it's also a matter of being disaster resilient, because when it comes to services like food, healthcare, you need to have the insurance and guarantee that even if the cloud computing, for example, is down, you're still going to be able to operate locally. And so I think this is certainly another great trigger to kind of look into edge computing. Would you agree?
Totally agree with you. Yes.
Very, very interesting. And Mahaveer, as we're coming to the end of our podcast, and I usually end with that question for our listeners who are interested in learning more and even starting a first exploration, what would be your 3 kind of advices that you would give them to get started?
I would say definitely, take a look at how you are computing in your organization today, right? What is the results that you're getting out of it? The second one is, what are the pain points that your organization looking to solve in next 6 months to 1 year, right? Is it cost saving? Is it improve what we call as revenue generation, improve the efficiency. And the next one is definitely security and data privacy. So if you're looking for any of these, and if you look and already started in your journey, are looking to start in your journey, as I mentioned earlier, IBM is here to help to discuss your organizational requirement, your business requirement, and technical challenges. Please reach out to us, either to me or to Lisa. We are available, and you can find us on LinkedIn as well. Or you can also Google IBM Edge Application Manager. You'll find our website. You can go there. You can take a look at various information available, and you can connect through our sales channel as well. If you have any questions, we are glad to answer those.
Great, thank you so much. I think this is a great way of concluding our conversation today. I, for sure, learned a lot today about edge computing, and I'm sure our listeners did as well. So a huge thank you to you, Mahaveer, and hope to speak to you soon again about edge computing or other innovative topics. Thank you so much for joining me.
It was great chatting with you, Lisa. Same here. And all the listeners, stay safe, take care. And thanks for your time and listening to IBM Edge Application Manager and the overall edge computing podcast here. I loved this discussion as well. Thank you.
I'm here. Thank you so much.
Thank you.